Hi, everybody. Thank you so much for joining me for this segment 2 exam review. We really appreciate the fact that you guys are time out of your busy schedules to take care of this before you take your exam, and we really hope that it will help you. So, before we start, just want to do a little self assessment. Think back on your note taking and how you did on the assignments in your class, and how do you feel right now? Like you're ready for the exam and just want a little refresher? So, this is just a little confidence booster for you, or like you really need a good review before you're ready for the exam, or like this is not even going to be enough. You don't remember anything. So, think about that and let's get started. So, we will start with Module 5, which is Antarctica. And basically, what I'll do is I'll go down. There's a whole lot of me talking since this is not a live session. It's just me really going over everything. And after most of the slides with the questions, there'll be all of the answers in red, so that if you need to, you can always go back and check over things that you might have missed, because I do tend to talk kind of fast. So don't feel like you've got to take notes all the way through. The answers will be here, and you'll be able to review and go back to look at that. So all animals in Antarctica have blubber to stay warm, which is that specialized layer of fat. Penguins also have feathers. Those soft underlying feathers are called down. They do not have fur. I've had many students say that penguins have fur. Penguins are birds. They don't have fur, but they do have very well insulated feathers. The male emperor penguins in the winter all get together in a big group to stay warm. That behavior is called huddling. The coolest thing about that is when the ones in the middle get warm, they actually voluntarily give up their spot and go to the outside of the circle so that the cold penguins can get to the middle to get warm. Penguin chicks hatch in the winter. This is important for their survival because in the winter there are very few predators around, so that gives them a good head start. And by the time they are old enough to hunt on their own and go hit the water, they're big enough to do that. The Adelie penguins fight over pebbles because they use pebbles for building nests, so the males will fight over the pebbles because they offer them to the females as a sort of a love offering, if you will, to try to get a mate. The penguin color pattern is called counter shading. The dark on their backs and the white on their bellies, if you think about them not standing up on land but in the water swimming, the darkness on the top, anything above them looking down, the dark top of their backs will blend in with the darkness of the bottom of the ocean, and their white underbellies, if anything is beneath them swimming looking up, it blends in with the sunlight coming down. So that helps them blend into their environment to avoid being spotted by either things that would want to eat them or the things that they want to eat. If you were to create a food web for the Antarctic, you would need to start with phytoplankton and zooplankton and then krill. And then from krill, you could go up to lots of different things, penguins or seals. And then penguins and seals can be eaten by killer whales or sharks. So the primary food source in the Antarctic is krill. You guys did a discussion about how important krill was. Baleen whales eat krill. Baleen whales are the ones that have kind of like a filtering plate in their mouth instead of teeth. So things like humpback whales and right whales, they're kind of like filter feeders, the grazers of the ocean. So they eat a lot of krill. I'm not even sure this was in your lessons that you did where it was, but it is on the exam. 70% of the world's fresh water is stored as Antarctic continental ice, and the icebergs are broken off chunks of that. The sea ice, excuse me, is salt water, so it's just frozen sea water, so that's called sea ice. And again, here's that slide with all of the answers on it for you. Currents. If you look at the picture on the top here, it kind of shows how the major currents of the oceans work. You can see that they pretty much go just in circles, with the warm currents originating at the equator and carrying warm water towards the poles, where the water cools and sinks, and then it's carried up towards the equator or down towards the equator, depending on which hemisphere you're in. So currents are very important because they redistribute warmth to the colder places. For example, the Gulf Stream, which is off the coast of Florida, goes up the North American East Coast and then across the North Atlantic, and it takes warm water to the British Isles. And so if you'll see at the bottom of this screen, it has that little yellow banner with essay. That means there is an essay question possibility for it. So it's going to ask why currents are important or how currents affect climate. So you need to talk about how warm water currents originate at the equator and carry warm water towards the poles. Cold water originates at the poles and cools down the land that it goes past on the way to the equator. Um, so very, very important for climate, general climate, as well as big weather events like hurricanes and things like that. Surface currents, the things that cause surface currents are wind and the Coriolis effect, which is Earth's rotation. Deep water currents are caused by changes in density, which you should remember is determined by the changes in salinity and temperature, and also bottom topography, which is basically what the landform looks like on the bottom of the ocean. Because if a current's going along and then all of a sudden hits a mountain or a valley, it's obviously going to change what that current does. Upwelling is when the cool, nutrient rich water from the bottom is pulled up to the top. So you remember from your lessons on density, things that are more dense will sink. Cold water is more dense than warm water, so it's at the bottom. And also all of the nutrients, which is mostly is a bunch of dead stuff, dead things, particles, detritus, that all sinks down to the bottom as well. So that cold water at the bottom has all of the nutrients. But most of the stuff that needs the nutrients is at the top in the photic zone where the phytoplankton is and most of the organisms that would eat the phytoplankton or the things that eat the phytoplankton. So the upwelling is super important to bring the nutrients up to the photic zone. The phytoplankton can use it. The zooplankton can eat it. The fish can eat it. So all of that stuff is great for fishermen because it means more and bigger fish. And here are those answers for you. So El Nino and La Nina are large scale weather patterns that occur periodically in the Pacific Ocean. So, in order to understand what happens during El Nino or La Nina, first you have to understand what the conditions are normally. So, normally in the Pacific Ocean, um, between Asia and Australia on the east side and South America on the west side. So if you imagine the Pacific Ocean in between them, normally there are strong winds that blow from the east to the west. They blow that top warm layer of water away from South America towards Asia, and that allows for a lot of upwelling because when that warm water is pushed away, the cold water from the bottom comes up. So, what that means is that the temperature is much colder near South America and warmer near Asia. The sea surface level is lower near South America because that water is being pushed away and higher near Asia. And as I just mentioned, there's a great upwelling on the South American coast. Great fishing, especially off the coast of Peru, because of that upwelling. So that's what it is like normally. When El Nino comes, that is when the winds that normally blow are weak or they don't blow. So because that warm water is not blown across, it kind of sits there off the coast of South America. The temperature is warmer than usual near South America, colder than usual near Asia. The sea surface level is higher near South America, lower near Asia, and the upwelling is diminished. So there are fish kills, the fish die off, and the fishermen can't catch any fish. Now, what happens usually a couple years after El Nino is the pendulum swings back and they have what's called a La Nina event, which is the exact opposite of El Nino. The winds are stronger than normal. They blow even more of the warm water away from South America. So the temperature is even cooler than normal at the South American coastline and warmer than normal in Asia. The sea surface is even lower at South America than it normally is and higher at the Asian side, and the upwelling is super strong at the South American coast. So here's a picture that will kind of explain what's going on or help you picture it. I'm not able to do any pointing on this, but if you look pretty much bottom of this picture where it says South Pacific Ocean, right around where it says Peru Current, if you can just imagine strong winds blowing to the left of the screen, right, blowing from east to west, that's the area that we're talking about. It's blowing that warm water over towards Southeast Asia and Australia, and that's where the El Nino and the La Nina weather patterns are occurring. Now, you probably know from the news that it affects weather all over the world, but that is where it all originates. Still in Module 5, you learned about hurricanes. The anatomy of the hurricane basically means you need to be able to identify the eye wall, and the rain bands. And you need to know that warm water is the thing that really fuels the hurricanes and gets them going. And then another essay question possibility is to understand the dangers created by a hurricane and which ones you are most likely to encounter. You obviously don't have to type anything in the chat box, but just think about whether it's storm surge, which is the inland pushing of the ocean, or inland flooding, or wind. Those are the things that typically come off of a hurricane. And so the essay is going to ask you personally, from where you live, what's most dangerous for you. So if you live very near the coast, you might say storm surge. If you live inland, but maybe in a low-lying area, you would say inland flooding and explain why. Maybe you live in a pretty protected area, but you've got lots of trees around. So the wind is the thing that you would be most concerned about. So that's just going to be a personalized essay based on your personal situation. So yeah, you've got the eye wall, and the winds of the hurricane, warm water, and then that essay that you'll just need to get prepared for. Another essay possibility, it just occurred to me, is how to prepare for a hurricane. So talk about protecting your valuables, having an evacuation route, packing everything up, getting out, or putting up storm shutters, or whatever it is you do to prepare for a hurricane based on where you live. And that's it for Module 5. For Module 6, we started out with coral reefs. Um, Coral reefs are very important for lots of different reasons. They are home to lots of different types of organisms. We get medicine from organisms on the coral reef. They act as barriers. A lot of reefs are barriers for coastlines that. So when we look at the details of a reef, reefs are typically located in warm tropical water between the Tropic of Capricorn and Cancer, pretty close to the equator, because they thrive on the warm water. They need lots of sunlight. They need clear water so that the sunlight can penetrate. They need constant salinity, and they need wave action to circulate the nutrients. The coral polyp is the organism that actually builds the reef by secreting calcium carbonate, which makes it hard. They have a special relationship with a certain kind of algae called zooxanthellae, and it's a symbiotic relationship because both organisms benefit from that. One of your essay questions basically says most coral reefs are in shallow tropical waters, but there are some coral reef that are deep water coral reef. The deep water coral do not have zooxanthellae, and the question is, why don't they have zooxanthellae? So you'll just need to kind of think that through. Zooxanthellae is an algae, so it's photosynthetic, so it needs sunlight to grow and produce energy. And there is no sunlight in the depths that deep water coral live. So if there's no sunlight, there can't be any zooxanthellae. Okay, so there are your answers. And oh, I think I said it was symbiosis. Mutualism is a form of symbiosis, so they want mutualism for that type of relationship between um, the polyp and the zooxanthellae. Okay, so here we have all the different types of mollusks, starting in the top right. That's a chitin, which is a member of the Polyplacophora, which means many-plated, and that's the only example that you need to worry about. They're not an important class, mostly because we don't eat them. The next one down, the next picture at about 2 o'clock, is a clam, and they are a member of the bivalve family. Bivalve means two shell, so that's the clams, oysters, scallops, and mussels. Underneath that, that cute little cartoon picture of a snail, that's a gastropod. Gastro means stomach. Pod means foot. So basically, they crawl around on their bellies, so that's why they're called stomach foot. So that's all of your snails and slugs. And then the bottom one there with the picture of the octopus, that's a cephalopod. Cephalo means head, and we just said that pod means foot. So because their head is attached to their feet, those are the head feet animals, and that's the octopus, squid, and cuttlefish. Estuaries. Estuaries are semi-enclosed bodies of brackish water. It's basically usually where a river meets the ocean, so where fresh water meets salt water. They are super important for lots of reasons. They're awesome nurseries. So lots of organisms that don't live in an estuary will travel to an estuary to lay their eggs, and then the babies and the juveniles stay there because it's a nice protected area until they're big enough to hit the open ocean. They also act as buffers to prevent inland areas from flooding. They act as filters to filter out nutrients and pollution before it hits the ocean. They act as waterways to transport goods up the river. They're highly productive. A lot of commercial fish and recreational boating goes on there. One of your essay questions is to talk about the estuary's pollution level. Estuaries are quite polluted. Not only do they receive a lot of runoff from um, buildings and commercialization from humans that build along and around estuaries, but they also receive water, so runoff from in the forms of streams and other rivers that will dump into an estuary. Um, but as I mentioned, they're important for filtering most of that out before it reaches the ocean. And the main source of production in an estuary is detritus, which is basically just little bits of dead things. Oh, there's a nice definition of it. Undissolved material from the decomposition of organic remains. So it's dead things, little bits of dead things. Module 6 also talked about nutrients and the problem with too many nutrients. So nitrogen and phosphorus are the two elements that are critical for plant growth, also for algae and phytoplankton. Um, Blue-green algae, which is a type of bacteria, are good for nitrogen fixation, which basically means most of the nitrogen um, in the ocean or even in the soil in the world is in a form that green plants and phytoplankton can't actually use. But these bacteria fix the nitrogen and convert it into a form of nitrogen that the plants and phytoplankton can use. So nitrogen and phosphorus are awesome. They're great. They're necessary for phytoplankton. But what happens when there's too much of them, a dead zone can be created. So what happens is when too much nitrogen or phosphorus gets in the water, it triggers an algae bloom, which basically means too much phytoplankton is growing too fast. And that will sit on the top of the water. It will block The atmospheric oxygen from dissolving in the water. It will keep the sunlight from reaching marine plants that would photosynthesize. But the biggest thing that happens is when the phytoplankton die, the process of decomposition, when it breaks down, uses up oxygen. And so anything that can swim away will swim away, and anything that can't swim away will die. So the dead zone is basically hypoxic. There's not enough oxygen for life, and there's the ladder of events of how that happens. The nitrogen and phosphorus um, can get into the water one of two ways. It can just be from a huge upwelling, but more often it's from runoff from farms and crops and things like that. Nitrogen and phosphorus naturally occur in manure and sewage, and it's artificially put in commercial fertilizers. So it's usually agricultural runoff or sewage that gets in the water that triggers the bloom. Module 7, so we are halfway there, guys. Module 7, The Abyss. The Abyss was an absolutely horrible horror movie in the 80s, so when I was your age, it scared the you-know-what out of lots of people. But it did make me learn what the word abyss meant. So, the abyss, the deep darkness. So organisms in the abyss are different because they've adapted to survive without sunlight. They have done this through different adaptations, bioluminescence. Some of them, like the anglerfish, have like a little light that hangs off the top of its head. It's super cool. You guys probably can best picture the abyss from the movie Finding Nemo, when they went down to the bottom there and you saw that anglerfish and the hydrothermal vents down there, which look like those miniature volcanoes. Those are basically kicking up chemicals and minerals from the Earth's core. And so since there's no light down there, there can't be photosynthesis, right? Because photosynthesis means energy from light. There's no light, so they have chemosynthesis, which is the production of energy from chemicals. So it's not plants or phytoplankton that are the primary producers. It's actually chemosynthetic bacteria. So if you look here, the picture on the like 3 o'clock, the third one down on the right, those are the chemosynthetic bacteria. They live in and on the tube worms, which is the picture right above them. The tube worms grow all around the vents. So the chemosynthetic bacteria are considered the primary producers. The tube worms are considered the primary consumers, and then you can go up and build a food chain from there. That top fish or eel that's really a dark picture at the top is the umbrella mouth gulper eel. And then the anglerfish is the orange fish at the bottom that has that little fishing lure off the front to lure fish in front of it so it can gobble it up. And then that viper fish, I don't even want to think about it. That's something from a nightmare. Still in Module 7, waves. This should be a total review for you guys. Pretty sure you've been learning about waves since middle school. So we need to talk about the anatomy of the wave. I'm just going to go ahead and go to the next one. So wind affects the waves because the energy from the wind is transferred to the water. That's what causes the waves. How big the wave is determined by the amount of energy that's transferred from the wind, and that's determined by distance, duration, speed, and fetch. Then if you look at the bottom of the picture, the lowest point is called the trough, the highest point is called the crest. The wave length can either be measured from crest to crest or from trough to trough. The height is measured from crest to trough, and to measure a wave period, you basically just count how much time it takes for two crests to go past a certain spot. Here's another big essay question that kids tend to do poorly on when I ask them on an oral quiz. So hopefully this will help you with this. There are two types of tidal events. There's a spring tide and a neap tide. It has nothing to do with the seasons of the year. It has everything to do with the arrangement of the moon and the sun relative to Earth. So because tides are created by gravity, The moon is much closer to the Earth, so it exerts a stronger gravitational pull than the sun, which is much further away. But the sun is ginormous, so it also exerts a gravitational pull on the Earth. When the Earth, moon, and sun are in a straight line, as in that first picture, it doesn't matter if the moon is on one side of the earth and the sun is on the other, or if the moon and the sun are both on the same side of the earth. If they're in a straight line, 180 degrees, that creates a spring tide. That happens at full moons and new moons. And because the moon and the sun's gravity are pulling in the same plane, the gravitational pull is multiplied, and so the tidal range is greatest, meaning high tides are higher than usual and low tides are lower than usual. And you can kind of see with the pull, in that first picture, it shows the dark spots. That's the pull, that's going to be the tide. The neap tide is the exact opposite. It happens at third quarter and first quarters of the moon when the sun and the moon are at right angles to the earth. So that bottom picture you see the earth, the moon is either directly above it or below it in the picture. Not both, obviously, one or the other. And then the sun is off to a right angle. Because the sun and the moon are pulling in a different plane, that means that the tides are lessened. The tidal range is the smallest. High tides are lower than usual, and low tides are higher than usual. Plate tectonics and continental drift both talk about the movements of Earth's crust and plates. Continental drift came first. Alfred Wegener proposed it, and he had lots of good evidence, including the puzzle-like fit of the continents. They just looked like they used to be attached to each other. Also had good fossil evidence, and some evidence of based on climate of the regions. All of that was fantastic evidence, but he couldn't explain how it happened. He just said he thought that it did happen because of the evidence. Plate tectonics came along after continental drift, and it explained how continental drift could have happened. So plate tectonics is the theory of the Earth's crust, that lithosphere being on different plates that sit on the molten magma, and therefore, they can kind of float around and move. Um, the essay question, I think there's two different ones. One is, how are those two theories related to each other? And they both talk about the movement of the Earth's crust. Plate tectonics explains how continental drift could have happened, so it sort of helps support the theory of continental drift. The other essay question is, why is plate tectonics considered a scientific fact and continental drift is not? And the answer basically boils down to, even though continental drift had a great evidence, we do not have a time machine. We cannot go back and see that, yes, all of the land was at one time in one huge, large landmass surrounded by one giant ocean. We just can't prove it. But plate tectonics, we can actually observe and measure. Classes of fish, there's really nothing to do here but memorize it. I'm going to start from the bottom and go up. So osteo, if you ever known anybody with osteoporosis, the prefix osteo means bone. So those are the true bony fish. And basically, if it's not agnatha or chondriichthyes, it is osteichthyes. Almost every fish you can think of is osteichthyes. Chondri, that prefix means cartilage. So the cartilaginous fishes are the sharks, rays, and skates. And basically, you just got to remember that. Sharks, rays, and skates have cartilage and not true bones. And then agnatha, that's just the thing from like the worst horror movie in the world, because that thing is creepy looking. A very prehistoric looking fish. It doesn't even have jaws. It's just got a big circle with a bunch of teeth. And the horrible way that I remember that is I think of Aunt Agnes. And if you have an Aunt Agnes who's a lovely person, I'm really sorry, you shouldn't use this, but that's just how I remember it. So agnatha are just the really old prehistoric creepy looking ones. Sharks, rays, and skates are cartilaginous. Everything else is a true bony fish, which is osteichthyes. These are the different color patterns that we see in fish. Counter shading, I already talked a little bit about when we talked about the penguins. That's when the top of the fish is dark, the bottom of the fish is light. You see this a lot in large predatory fish, sharks, things like that. That is very helpful in the deep ocean or the water column because remember, for it to work, things have to be swimming above you or below you, right? So that's in the deep water. Cryptic is what we think of when we normally think of camouflage. These fish can actually um, change the color of their skin to blend in with their surroundings. They're often have a depressed body shape and stay on the bottom of the ocean. They usually start out as a dull color like sand or brown or tan or rock colored. So toadfish, frogfish, flounders, even stingrays, that those are cryptically um, colored. Disruptive are the brightly colored fish with bold patterns and things like that. And the idea there is not so much that they blend in with their surroundings, but that their predators can't really tell where to attack because they don't really see a head, a body, and a tail. They just see like this weird pattern. So it's hard to even pick them out as a fish, perhaps. That's common in coral reef fish and also schooling fish because if you think about it, the only thing better than that crazy pattern is to be in the middle of 100 other fish with the same crazy pattern. So predators really can't pick them out. Some land animals have this color pattern as well, like zebras. When you watch a lion go to kill a zebra, it never attacks while they're in the herd, right? They always wait till one is cut away from the herd. It's not really so much that they're afraid that the zebras are going to attack them if they're all together. It's because until it's cut out from the herd, it can't really see the head or the tail. It just sees all of the stripes. So that's how disruptive works. Shapes of fish. Fusiform is just a streamlined shape that's for fast swimming. Compressed means it's squished in from side to side. So that's good for getting in between like the crevices of a rock or things like that. They're not fast swimmers, but they can wiggle well. Attenuated is basically like an eel, things like that. It's an elongated shape that's really good for getting into holes. And then depressed is flattened from top to bottom. So compressed is from side to side, and depressed is from top to bottom. And those are usually bottom dwelling fish, they hang out on the bottom. Also in Module 7, mangroves. You should have learned a little bit about mangroves also back in Module 6 because mangroves are often found in estuaries. An essay question about mangroves is to explain why they're so important. Mangroves are super important as habitat for young fish. The babies can hide up in those roots and stay safe. They also help prevent erosion by trapping sediment in their roots. They can actually build islands just by grabbing onto that soil and building up and growing. They've got all sorts of special cool adaptations to live underneath the water and above the water and to get rid of salt that they take in. Super duper important plants. I don't even think it's on the test, but just a fun fact. They have pneumatophores in their roots that help them get oxygen out of the soil. So those are called pneumatophores. And just like that, we are in the last module. One of your essays is to discuss 4 destructive fishing methods. So the 4 that you learned about in Module 8 were stern trawling, gill netting, purse seine lining. So I know that you also learned about cyanide fishing and explosives back in Module 6. But for the purpose of this essay, you want to talk about the commercial fishing methods. So those back in Module 6, remember, those were like small fishermen in little island countries. These are massive commercial fishing methods. So you need to talk about why they're bad. You need to talk about bycatch, which is catching things that they're not fishing for. So if I'm fishing for tuna and I catch, you know, flounder and brim and redfish. Anything else that I catch, brim is freshwater, sorry about that. Anything else that I catch that's not what I was fishing for is bycatch. And the problem with that is most of it is a complete waste. It ends up dying on the boat and then just dumped back in the ocean, and it's completely wasteful. Also, you need to talk about overfishing, the fact that all four of those methods catch many, many more fish than is necessary, and they're not leaving enough fish in the ocean to replenish the stocks. So, because of that, the fisheries, commercial fisheries, are on the decline. Also, when you talk about problems with it, if you talk about the stern trawling, the bottom trawling, that's a ginormous net that they drop all the way down to the bottom of the ocean, and they weigh it down with concrete or steel and drag it along the bottom. So, in addition to bycatch and overfishing, the problem with that is habitat destruction, because they'll drag it right along the top of, kelp or a seagrass bed or coral or whatever is there, which will destroy the habitat. When you talk about marine mammal classification, again, I'm not really sure how to help you with this except to just say memorize it, have it in your notes, and be ready for it. Penny means flipper, ped means foot. So the pinnipeds are the seals and walrus. Sirenia, those are the manatees and dugongs. Fizzy means pad or paw, and you just learned ped and pod mean foot. So the fizzipeds are actually, there's both the sea otter and the polar bear are in that group. Um, Cetaceans are completely aquatic. They cannot survive on land. So whereas the pinnipeds and the fizzipeds have feet and do go on land, they're semi-aquatic. Cetaceans cannot come up on land. And so you've got two major categories there. Odontoceti. Odonto means tooth, right? If you go to an orthodontist, odonto is tooth. So those are the sperm whales, orcas, and dolphins. And then the mysticeti are the ones that are baleen filter feeders, like the humpbacks and right whales and things like that. And they do not use echolocation like the other ones do, simply because they're grazers, right? They just swim around with their mouths open and filter feed all of the krill and zooplankton. So they don't really need to hunt. They don't need to chase anything down, so they don't need that echolocation. Module 8 also has a couple other essay question possibilities. Reasons for not feeding wild dolphins. Why should you not feed dolphins in the wild? First of all, the food that you feed them could be bad for them. Secondly, it can interfere with the mother calf bond. Instead of the mom teaching the calf how to hunt, she's competing with him for handouts. The food will start making dolphins attracted to boats. They start associating boats with food. They get close. They are much more likely to get hit by a boat propeller or caught up in a fishing line or a fishing net. The dolphin could lose its instinct to hunt, and you could get bit. There you go. That was 5. I gave you an extra one. The keystone species of the kelp forest is the adorable sea otter, because it is one of the few things that will eat a sea urchin. So sea urchins eat kelp. Kelp is in that upper right-hand corner picture. And it doesn't just graze on the leaves, because you look at it and think, well, big deal, man, there's a ton of it. It should be able to eat what it wants. They eat the holdfast of the kelp, which is basically like destroying the root system of a plant. So it uproots the kelp, and the kelp will just float away. So it's not just grazing on it. It's killing the kelp, and which removes not only the primary producer there, but also the habitat for all of those organisms. The sea otter eats the urchins. If the sea otter was not there, the entire kelp forest would be destroyed. So that's why it is considered a keystone species. Common items containing kelp and other algae, you did that. You went through it. Things like anything with a thickening agent, like gravy or the macaroni and cheeses, things like that. A lot of times, ice cream, and even non-products like makeups and things like that. Wow, we did it. We did it quickly. So now we checked in at the beginning. We're going to check in now. How do you feel? Do you feel great? You ready to take the exam? Go ahead and get your password and take it and do well. If you feel pretty good, but you're going to review a little bit more, that's a great idea. You can go back and look over this presentation again, or just, spice up your notes a little bit. If you still don't think you remember anything, I would just say start over and listen again. Maybe write some things down. And if there's just a handful of things you're not sure about, make sure that you go ahead and take that up with your teacher. And that is it. Again, I thank you so much for your time. I know you are going to do fantastic. Good luck.